So what real-world solutions does your product offer? Different examples that we may have discussed.
Okay, well, I've talked about the UN refugee folks in Uganda, the Nigerian medical facilities that are all over Nigeria and frankly all over Africa. But there's other examples. For example, here in the US, we're in communication with photovoltaic manufacturers. They're trying to put in photovoltaic plants in back east, in the states like South Carolina, North Carolina, and Virginia. And they're trying to put in solar panels, but they don't have storage. So here's a situation where if this is time of day, here's when the sun rises, here's where the sun sets, and solar energy appears, they call it the solar peak, right at solar noon. But the load peak, what the utilities have to put up with, is 5 or 6 hours later. 5 or 6 in the afternoon is the load peak. So you have these two peaks, and to get from where you generate it to where you use it, to get that 5 or 6 hours, you need a way to store that electricity. Or what we do is we don't store it as electricity, we store it as heat, and then later we can tap into that with our generator set, so we can deliver energy when the family needs it, which is to say in the evening, their air conditioning, their lights, and so we have a kind of a complementary possibility or compatibility with photovoltaics. They're not our enemy if you combine both of these. So we're talking to people that put in solar farms, and the value of the solar farm would be to put half photovoltaic and half of our microgrids. Now in a solar farm, we separate out these three functions. There's the collection function, which our linear Fresnel mirrors do. There's the storage function, we store and heat. And then there's the generation function. And so in our microgrid, all three of these are in one box, container. But in a solar farm, the collectors are separate from the heat storage and from the generation.